Ready to blast off into the future? We're diving deep into space exploration and colonization today.
Sounds exciting.
We've got some fascinating excerpts from a Spanish research document.
Oh,
It's called volumen12.pdf, and it lays out a roadmap, at least that's what it feels like,
a roadmap.
for Spain's role in space exploration.
Spain's top scientific agency, CSE.
Exactly. We're going to uncover the challenges, the opportunities, all that jazz that come with going beyond Earth.
You know, one thing that struck me about this document is how it presents space exploration as like this natural next step for humanity.
Oh, I see.
Like it's in our DNA to explore. They compare it to, those early explorers.
Setting sail for new land.
Yeah, uncharted territory. And space is like the ultimate uncharted territory now.
Makes you think, right? Like that drive to see what's over the horizon. Is it just like hardwired into us? And this time, the horizons.
Yeah.
Well, it's the entire universe.
It really is.
But this document isn't all just big ideas. They get down to the nitty-gritty of actually establishing a human presence out there.
Oh, yeah. They're talking about more than just planting a flag on the moon. They're looking at utilizing space resources to fuel further exploration, like by 2030.
2030.
They're envisioning using lunar resources, think water, oxygen, even metals.
Wow.
And get this, by 2040, a sustained human presence on the moon.
A sustained presence. So we're talking
More than just quick visits.
actual lunar communities.
Exactly.
That's wild. Okay, so the moon is obviously a prime target, but what about other celestial bodies? What about Mars?
Mars is definitely up there.
Right.
But they also talk about the potential of Venus to understand planetary atmospheres, and even those icy moons like Europa,
Oh, yeah, those are fascinating.
which could have huge oceans under the ice.
So we've got a whole solar system of potential outposts, essentially.
We do.
But let's get real for a second. Hauling everything we need from Earth
Yeah.
doesn't seem sustainable, does it?
That's where ISRU comes in.
ISRU.
In situ resource utilization.
Living off the land, but in space.
Exactly. And the document really pushes ISRU as like the key to making this whole thing work long term.
I see.
Like imagine this, fueling your spacecraft
Yeah.
with water ice mined from the moon's craters.
It's an incredible image, but turning that image into reality can't be easy. What kind of technical challenges are we talking about with space mining?
Well, first you've got to find the resources, right?
That's true.
Prospecting on the moon or Mars, it's not as straightforward as it sounds.
I imagine not.
And then you've got the whole thing of developing technologies to extract the stuff efficiently and reliably and all this in crazy environments.
Yeah, the conditions are brutal.
And did you know lunar regolith is actually more abrasive than the powders we're used to on Earth
Really.
because of the lack of, well, wind and water erosion?
So even something as seemingly simple as digging on the moon
It's tricky.
has its own unique hurdles. Okay, so we got the raw materials. What about actually building structures in space? Homes away from home.
Oh, that's where things get really interesting. Imagine. Habitats 3D printed from lunar regolith, or even repurposing caves on the moon or Mars as shelters.
Living in a lunar cave. Okay, that does sound kind of awesome.
Yeah.
But beyond the cool factor, what are the big challenges with constructing a livable environment in space? What are we up against?
Well, a big one is shielding against radiation. And then there's the whole question of artificial gravity.
Right.
Maintaining a breathable atmosphere in a confined space.
Right.
There's even concerns about noise pollution and acoustics in these habitats.
It's amazing how many things we take for granted here on Earth suddenly become huge issues when you're talking about space. With all this talk of lunar and Martian real estate, I got to ask, who owns this stuff?
The Wild West of space law.
Exactly.
The Outer Space Treaty of 67, it talks about, free exploration and use of space.
Right.
But it doesn't really address resource extraction specifically. And then there's the Moon Treaty, which says the moon is like the common heritage of mankind.
Right, right.
But a lot of the major spacefaring nations haven't really signed on to that one.
So it's still a bit of a gray area then.
It is.
We're basically making up the rules as we go along.
In a way, yeah.
But before we get too caught up in property rights, can't forget about planetary protection.
Absolutely.
We got to make sure we're not contaminating other planets.
With Earth stuff.
Yeah, and vice versa.
Yeah.
Especially with missions like, I don't know, the Mars sample return.
Right.
Presenting biological contamination is crucial.
It is.
So amidst all this talk of moon bases and Mars settlements, Where does Spain fit in?
Well, this document emphasizes how CSE, Spain's big science agency,
Right.
how they can play a key role in all this.
Interesting.
They see themselves as having the expertise
Yo.
to lead in developing cutting-edge tech.
For what?
For resource extraction, construction, you name it.
Wow.
They're envisioning CSEC at the forefront of scientific investigations.
Into what exactly?
Planetary geology, atmospheres, even the search for alien life.
Ambitious.
Yeah.
But it sounds like they're ready to take on the challenge.
They are.
It's exciting to see a nation really stepping up and saying, we're going to be a part of this future. What are some of the specific areas where they're looking to make an impact?
Well, they're big on robotics for those extreme environments,
Makes sense.
pushing 3D printing for habitat construction,
Right.
and designing those next-gen space instruments.
So from mining to building to actual research, CSEC wants to be involved in it all.
Pretty much.
What stands out to you about their approach?
What I find interesting is their focus on how everything's connected. Like developing new technologies is crucial for scientific advancements and vice versa.
It's a holistic approach then.
Exactly. It's not just about getting to space. It's about figuring out how to actually thrive there.
That's a key distinction. It's not just about planting a flag.
Right.
It's about building a future beyond Earth, a sustainable one.
And they're not just talking about it. They're already doing it. For example, they're developing tech to extract oxygen from lunar rocks,
Really?
using this process called molten salt electrolysis.
Molten salt electrolysis. I'm not familiar with that one.
Well, it involves using electricity to break down molten salts.
Okay.
And in this case, they're looking to use it to get oxygen from the lunar regolith.
Ah, so turning moon dust into breathable air.
Essentially, yeah. It's complex, but it could be a game changer for creating an atmosphere on the moon.
Wow. It's incredible to see this level of innovation being applied to space exploration.
It is.
But it's not just about technical solutions, right?
Of course not.
What about the human element? The psychological challenges of living in such an extreme environment?
That's something CSIC definitely considers. They're looking into ways to deal with the effects of, well, prolonged exposure to microgravity.
Right, which can wreak havoc on your body.
Exactly. They're also exploring ways to create artificial gravity environments.
Artificial gravity. That sounds like something straight out of a movie.
It does, doesn't it? But they're looking into using centrifugal force.
Like spinning habitats.
Yeah, to simulate gravity. It's still early days for that research.
Of course.
But it's a fascinating possibility.
It really feels like we're on the verge of a whole new era of space exploration.
It does.
And the best part, it's not just one nation leading the charge.
Right.
It's a global effort, a testament to our shared human desire to explore. So we've talked about the challenges, the opportunities, the vision for the future. But how do we actually get to these far-off places? What about the engines, the propulsion systems?
Now, that's a question for our next deep dive.
Oh, a cliffhanger.
Get ready to explore the world of ion drives, nuclear thermal propulsion,
Sounds intense.
and maybe even warp speed.
Okay, now you got me really hooked. Can't wait to delve into the mind-boggling world of space propulsion in Part 2. Join us then as we continue our journey to the stars.
Back for more space adventures.
You bet. We're diving deeper into this CSIC document. And it's clear they've given a lot of thought to how to make space livable. You know, in Part 1, we talked about the why of space exploration.
Right.
Now it's time to tackle the how.
And a big part of that how is figuring out where to find the stuff we need.
The resources.
Exactly. To build and sustain a presence beyond Earth, this document really breaks down what we can expect to find.
On the moon, Mars, even asteroids.
That's right.
Now, we already touched on water ice being a major resource on the moon.
Especially in those craters.
Yeah, the permanently shadowed ones at the poles.
Right.
But what about other lunar treasures? What else is the moon hiding?
Well, the moon's got this surprising variety of minerals: silicon, aluminum, iron, magnesium, titanium.
Wow, it's a veritable periodic table up there.
It is, and you could use these for all sorts of things.
Like what?
Building habitats, making solar panels, even producing components for advanced technologies.
It's wild to think we could have a whole lunar industry one day.
Oh, imagine that.
Mining raw materials, manufacturing products. Oh, all right there on the moon.
Exactly.
Oh.
And that's where CSIC's expertise in robotics comes in.
Ah, yes.
They talk about developing these like specialized robots,
Right.
carrying out these complex mining operations.
In that harsh lunar environment.
Yeah, it's not like we can just send a bunch of miners up there with pickaxes.
Right, we're talking autonomous robots.
Maybe even 3D printed on the moon itself.
Using local resources.
Exactly. Robots working tirelessly in extreme temperatures in a vacuum.
It's mind-blowing. They even talk about using something called electrostatic sorting.
Oh, yeah, to separate those different particles in the lunar regolith.
Right.
Using those electrostatic forces, you can separate them by size and electrical properties.
That's incredible. So we can efficiently extract the valuable minerals from all that lunar dust.
Precisely.
Okay, so we've covered the moon. What about Mars? What's the resource potential looking like on the red planet?
Mars is kind of similar to the moon when it comes to the minerals you find there. Lots of basalts, metal oxides.
And regolith, of course.
Of course. But the really exciting prospect on Mars is the water.
Water?
Yeah, there's likely water ice beneath the surface, and maybe even liquid water in some places.
I remember reading about evidence of possible liquid water flows on Mars. That would be a game changer, wouldn't it? For establishing a long-term human presence.
Oh, absolutely. Even if we only find water ice, that's still incredibly valuable.
And unlike the moon, Mars has an atmosphere.
Thin, but it's there.
Meaning we could extract gases, right?
Yeah.
Like a carbon dioxide, nitrogen.
Exactly. And you could use those to create a breathable atmosphere within those Martian habitats.
And maybe even for growing plants.
Precisely. And then there are asteroids. Those might seem like just big rocks flying through space.
Right.
But a lot of them are packed with valuable metals: iron, nickel, platinum.
It's incredible to think those space rocks could hold the key to expanding our footprint in the solar system.
They could. We could be talking about mining outposts on asteroids.
Wow.
Extracting resources to build and fuel spacecraft for deep space missions.
It's like a cosmic gold rush. But getting those resources from asteroids can't be easy.
It's not. We're talking about capturing and securing these celestial bodies.
Right.
Developing specialized mining equipment for those zero-gravity environments. And then safely transporting all that stuff.
Back to Earth.
To Earth, or maybe to our outposts in space.
It boggles the mind. The sheer complexity of these operations.
It is pretty amazing to see how we're figuring this all out, though.
It speaks to our ingenuity, for sure. Our drive to explore and push the limits.
Absolutely. And it's not just about the technical stuff. CSIC also talks about something else.
What's that?
Sustainable practices for all this space resource utilization.
Sustainable practices. What does that even mean in the context of space?
Well, it means minimizing our impact on those environments. On the moon, Mars, wherever we go.
Makes sense.
And it also means developing closed-loop systems, where waste products get recycled and reused.
So we're creating these like self-sustaining ecosystems.
Exactly. Like composting, but on a cosmic scale.
I love it. So it's all about creating a circular economy in space.
Using and reusing resources to rely less on Earth.
To ensure we can actually stay out there long term.
That's the goal.
That's an incredible vision. Okay, so we've talked about mining and resources, but what about actually building structures in space? What kind of habitats are we envisioning here?
This is where CSIC's expertise in 3D printing comes into play.
Ah, yes.
The document talks a lot about using 3D printing to create habitats.
Using those locally sourced materials.
Exactly. Lunar regolith, Martian soil, even processed metals from asteroids.
We talked about 3D printed habitats before, but can you paint a picture of how this would work in space?
Picture this. Robots with 3D printers land on the moon, and they start using lunar regolith to print entire buildings.
Wow.
Layer by layer. It's incredibly flexible design-wise, construction-wise, and it means we don't have to launch as much stuff from Earth.
It's like building a sandcastle on the moon.
In a way, yeah, but much more sophisticated.
Of course.
Yeah.
But wouldn't we need some serious radiation shielding for those structures?
Absolutely. Radiation's a big concern. And the document explores various shielding options. One idea is incorporating it into the 3D printed structures themselves.
How?
Layering different materials with varying densities, so the protection is built right in.
Instead of having bulky external shielding.
Right. They also talk about underground habitats.
So the lunar or Martian soil provides natural shielding.
Exactly. And they even consider repurposing existing caves.
Living in a lunar cave. That sounds both creepy and cool.
It does, doesn't it? But caves could provide protection. from radiation, meteor impacts.
A ready-made shelter, basically.
You just have to adapt it a bit.
Speaking of adapting to space, we often see artificial gravity in sci-fi. Is that something that's actually on the table? Artificial gravity always seemed pretty far-fetched to me.
It's definitely a challenge. But the document doesn't rule it out completely. They mention using centrifugal force.
Oh, like spinning habitats.
Yeah, to simulate gravity. It's still early days, research-wise.
Of course, of course.
But it's an intriguing possibility.
I mean, if we could create artificial gravity...
It would be revolutionary. Make living in space much more like living on Earth.
It's amazing to think we might be able to recreate gravity out in space. But even if we nail the technical stuff...
Like building structures, creating artificial gravity.
There's still the human factor. The psychological challenges of living in such an isolated and confined space.
Oh, that's something CSIC takes seriously. The document stresses the need to design habitats with well-being in mind.
Makes sense.
They talk about things like lighting, color.
Really?
Even simulating Earth's day-night cycle to help regulate our bodies.
It's like designing a cruise ship for space.
In a way.
But instead of a few weeks at sea, we're talking months, years in a closed environment.
Yeah.
You need a space that's comfortable, stimulating, not just functional.
Exactly. And they also emphasize fostering a sense of community within those habitats.
So people don't go stir crazy.
Yeah. Creating opportunities for social interaction, recreation, all that.
Makes sense. Even with the wonders of space to explore, you still need that human connection.
Absolutely. And speaking of exploring space...
How do we actually get to those distant destinations? We haven't even talked about propulsion systems yet. The engines that will power us to the stars.
Right. That's a whole other topic.
A topic I'm super excited to dig into. From what I've read, our current chemical rockets aren't going to cut it for interplanetary travel.
They're powerful, but not very efficient.
Right. We need something a bit more futuristic.
That's where technologies like ion propulsion come in. CSIC is very interested in this for deep space missions.
Ion propulsion. That sounds like something straight out of Star Trek. How does that even work?
Well, science fiction often predicts future tech. Ion propulsion uses electricity to accelerate ions.
To create thrust.
Exactly. And it's much more efficient than chemical rockets.
So we can travel farther, use less fuel.
Right. It's a trade-off, though. Ion thrusters produce low but continuous thrust.
So it takes longer to accelerate.
To reach those high speeds, we're talking months, maybe even years for those interplanetary trips.
So slower travel times, but much greater fuel efficiency.
Got it. Are there any other propulsion systems on the table for those deep space journeys?
CSIC mentions nuclear thermal propulsion as a potential game changer.
Nuclear. Isn't that a little risky? Launching nuclear reactors into space.
It does raise some safety concerns, definitely. But the potential is huge. Nuclear thermal propulsion uses a nuclear reactor to heat propellant, usually hydrogen.
To super high temperatures.
Right. And that creates a much higher exhaust velocity compared to chemical rockets, meaning faster acceleration, shorter travel times.
So we could potentially cut travel time to Mars down to weeks instead of months.
Potentially, yeah. But there are hurdles, obviously. Technical, safety.
And ethical considerations as well, I imagine.
Absolutely.
Yeah.
And the document acknowledges all that. It's not a technology to be taken lightly.
That's good to hear. While we're on the topic of futuristic propulsion, what about warp drives? Wormholes? Are those even remotely possible? Now we're entering the realm of theoretical physics. Warping space-time, creating shortcuts through wormholes.
Sounds pretty wild.
It is. The concepts are fascinating, but we're talking pure speculation at this point. The laws of physics, as we know them, don't necessarily say they're impossible.
Right.
But the technological challenges are mind-boggling.
So no zipping across galaxies anytime soon.
Probably not. But who knows what the future holds? Maybe one day warp drive will go from science fiction to science fact.
Like your optimism.
Yeah.
Okay, so we've talked about mining on the moon and Mars.
Yeah.
3D printed habitats, even those super advanced propulsion systems. But let's bring things back down to Earth for a minute. What about the impact of all this space exploration on our own planet?
That's a great question. Historically, space exploration has led to tons of innovation.
Right.
Spin-off technologies that end up benefiting society in all these unexpected ways. Think GPS, satellite communications, even medical imaging. All those have roots in space exploration.
So investing in space is also investing in our future here on Earth.
Exactly. The technologies we develop for space often have applications right here at home, in energy, medicine, environmental protection. And as we push further into space, that's only going to continue.
It's exciting to think about how searching for knowledge in space can lead to solutions for problems here on Earth. It
Yeah.
really highlights how interconnected everything is.
It does, and CSIC gets that. Their approach to space exploration isn't just about science for science's sake, it's about how those advancements can benefit everyone.
It's a vision that captures the imagination, reaching for the stars, but also staying grounded in our commitment to a better future for everyone here on Earth and beyond.
Absolutely.
Ready for the final frontier. In this last part of our deep dive, we're going to explore the engines that could power our journey to the stars, propulsion systems.
This is where it gets really exciting. This section of the CSIC document, it dives into the cutting edge of space travel, pushing the boundaries of what's possible to reach those distant destinations.
We've talked about traditional chemical rockets, good for getting us off the ground, but not so efficient for those long hauls. What are some of the alternatives that CSIC is looking at?
One of the most promising is ion propulsion. It's already in use on some spacecraft.
Right.
And CSIC sees it as a key tech for those future deep space missions.
Ion propulsion. That sounds like something out of Star Trek. Remind me how that works again.
It's pretty amazing, actually. It uses electricity to accelerate ions,
Okay.
to create thrust. And the cool thing is, it's way more fuel efficient than those traditional chemical rockets.
So we can travel much farther using less propellant.
Exactly.
So it's kind of like an electric car for space,
Yeah, I like that analogy.
trading raw power for efficiency and range.
There is a trade-off, though. Ion thrusters, they provide a low but continuous thrust,
Okay.
meaning it takes longer to get up to speed. We're talking months, even years of travel time for interplanetary missions.
Patience is a virtue for those space travelers then.
It is.
But if it means getting to Mars or beyond using less fuel, I'm all for it. What about other innovative propulsion systems? Anything else in the works?
CSIC is also exploring nuclear thermal propulsion.
Nuclear propulsion. Now that one's a bit more controversial.
It is, but it offers the potential for much faster travel times.
Okay, I'm intrigued. How does that work?
So nuclear thermal propulsion, it uses a nuclear reactor to heat a propellant, usually hydrogen,
To really high temperatures.
extremely high. And that creates a much higher exhaust velocity than with chemical rockets. Faster acceleration, shorter travel times.
So we could be talking about cutting a trip to Mars down from months to weeks.
Potentially, yeah. But of course there are challenges, safety concerns with launching nuclear reactors into space, and there are the ethical and political considerations as well.
Right, it's not a technology to be deployed lightly. It sounds like CSI is approaching it with the appropriate level of caution. But while we're on the topic of futuristic tech, what about those sci-fi favorites? Warp drives, wormholes? Any chance of those becoming a reality?
Those are the holy grails of space travel, aren't they? Warping space-time, creating shortcuts through wormholes.
It's mind-blowing stuff.
It really is. But for now, they're still in the realm of theoretical physics. The laws of physics as we know them, they don't necessarily say they're impossible, but the technological hurdles, they're enormous.
So no interstellar joyrides anytime soon.
Probably not. But hey, who knows what the future holds, right? Maybe one day warp drive will go from science fiction to science fact.
I like your optimism. Okay, so we've talked about mining on the moon and Mars, 3D printed habitats, even ventured into the realm of super advanced propulsion. But let's bring it back down to Earth for a moment. We've talked about how space exploration can benefit humanity's future, but what about its impact on our own planet? Right here, right now.
That's a really important point. Space exploration has this amazing track record of spinning off technologies that end up benefiting society here on Earth. Think about GPS, satellite communications, even medical imaging. All those have roots in space exploration.
It's incredible to think our quest to explore the cosmos is having such a tangible impact on our daily lives.
Absolutely. And as we keep pushing further out into space, that trend is likely to continue. The tech we develop for space often finds applications in all sorts of fields: energy, medicine, environmental protection.
So investing in space exploration isn't just about expanding our knowledge of the universe.
It's about investing in a better future for everyone, here on Earth and beyond.
It's a vision that captures the imagination, doesn't it? Reaching for the stars, but also staying grounded in our commitment to a better future for all.
It really does.
Well, it's been a fascinating journey exploring this document with you, from the challenges of space mining to the possibilities of those 3D printed habitats, and even those mind-boggling propulsion systems. CSIC has laid out a really ambitious and inspiring roadmap.
for Spain's role in shaping the future of space exploration.
It's a future filled with challenges and opportunities. It's exciting to think about the role each of us might play in this grand adventure. Whether we're contributing to scientific discoveries, developing groundbreaking technologies, or simply gazing up at the stars in wonder, we're all part of this journey. Thanks for joining us on this deep dive into the future of space exploration. Keep looking up. Who knows? Maybe one day you'll be living on the moon or traveling to Mars.